Okay, as Allison said earlier, I am Gwen Malone, and as of the beginning of this year, I'm responsible for ergonomics manufacturing, what we call manufacturing ergonomics for GM, or it's global GM. And wanted to just spend a little time on why we need 3D human simulations. We want to be able to identify issues early, and we want to identify those in math, as Allison talked about. But we also want to create the opportunity to work between the product engineering organization and the manufacturing engineering organization that receives the product. And as I've been spending a lot of time in vehicle assembly plants this year, every time I leave one, I have that old song, plop, plop, fizz, fizz, because when I look at how a vehicle actually goes together, you're pushing parts, operators are pushing and meshing parts, and meshing garnish, trim, what we call A-pillars, B-pillars, and C-pillars, and that all changes depending on the body style. So the product of a vehicle very much dictates a lot of the issues we see from a human factors or an operator interaction standpoint. And we want to design for assembly and manufacturing, support our new and major program launches, and there are many. Look at product designs, just as Allison said, where I can get my hands around the part. Do I have enough clearance? If I don't have enough clearance, then I'm going to either need some sort of hand tool, or the operator will, we're going to reduce the force in that component of part. And if we reduce the amount of force we allow in that component of part, will it in fact turn out to be a quality issue? So there are all of those issues that we continue to deal with. We look at, we also do a lot of designing of our containers and our racks, getting the parts to the assembly line and what that looks like, how it's staged, can the operator reach them. And again, once you're able to kind of pull all of this information together in math, what you've done is really created a nice library. You can go back and start in the middle of a scenario versus starting over when you're actually trying to build the next assembly line, the next engine line, the next transmission line. So that is that's our reason why we've been playing in this for a number of years. And you know, all of this goes into reducing the number of injuries and illnesses in our plant. So we have this kind of hierarchy and funnel, and the ultimate goal is making sure that the operator goes home at the end of the day exactly the way they came in. And it also reduces cost on a variety of ways. So what we do with our 3D simulations today, just as Ford and John Deere, didn't want to say Caterpillar. Didn't want to say Caterpillar. We also use the Siemens suite of tools, Jack and Jill. We've been using Classic Jack, and we've been able, and with some work from the University of Michigan in Unison. We've done a few things. We have created what we call our GM Global Anthropometry. So we're able to look at the sizes of the operators around the globe and do simple reach studies, interchange different mannequins, so we can take a 50th percentile female, exchange it fairly rapidly with a 95th percentile male, comprehend what that operation is going to look like. We can do pretty detailed static postures and joint analysis, and hand clearances. How much clearance do I have? Do I need to start looking at reducing forces if I don't? Operator line of sight are things we can do. The operator walking along an assembly line, it's a little rough, but we can still do that, and that's getting better. And then evaluating the overall work height for an operator. And what do we need in the future? Seamless importing of whatever the digital human model that as Allison said, two-prong, maybe three-prong approach into our Siemens PLM system. And one of the things I didn't mention is that we also have this opportunity now to look at some process simulate parts of Siemens, which allows a little more easier improvement of the DHM, but it doesn't necessarily play with some of the overlays that we've done from Unisim. So as companies continue to evolve, it is pretty important for us to continue to look at all aspects of the models that are out there. We want continuous improvement in accurate and realistic simulations, and what's really important is dynamic simulations, the comprehension of predictive forces. And as Allison said, we've been working with Santos through the U.S. car now for 5 years, and that's pretty important to us. That's why we're playing it, is that we need to really be able to comprehend how much force it takes for an operator to install a spark plug wire into a engine block, how much force it takes to reach up, and what's the predictive force when you're installing an A-pillar in the top of the car, on the side of the car. So those are all important, as well as looking at predictive forces of components or the work we're performing. And we have some internal research going on in that as well. We have to continue to increase productivity and efficiencies. I mean, that's one of the reasons why we've been playing here. We've been able to show that we have an increase in effectiveness, productivity, and efficiency with the tools that with the tool sets that we're using and the toolkit that we've developed and working with University of Michigan. So we can't go backwards. We have to be able to continue increasing productivity. And what is also important on some level is the ability to bake in some of our GM internal standards, so that we're not using 4 or 5 different systems, but we're able to actually transition between the different attributes of the DHMs that we choose to use. So that's kind of why we're doing it, what we're using, what we expect. Okay? Thanks.